Welcome to Bednik Tutors YouTube channel. In this channel, we will be breaking down topics of each science subject in order for you to have a better understanding of each topics. Because as a teacher, we believe that every student should understand fully every topics they are being taught. So, in order not to miss out on any of our videos, because all the videos we'll be uploading are very important, please do well to subscribe to our YouTube channel. Also, like and share. We also have a Telegram channel where you can communicate with us, ask us questions, and meet with other educators. The link of our Telegram channel is in our YouTube bio and comment section. Now, say these after me. I understand mathematics. I understand physics. I understand chemistry. I understand further math. That is a spirit. Basic tutors. Excellence is our word.
Good morning, beloved. We'll be looking at motion. So, our major work this morning has to do with linear motion. So, we have different type of motion. We have the linear, we have the motion under gravity too. We talk about vertically upward motion, vertically downward motion. Then we also talk about projectile too in physics. But our major work this morning will have to be with linear motion. So we'll be doing a lot of calculation around linear motion. Mind you, this one is strictly on calculation. We're still going to discuss the theoretical aspect, like the essay aspect of motion. We're still going to discuss that. But I still want us to concentrate for now on calculation involving linear motion. We'll be doing a lot of things about the laws of motion. Motion has to do with changing the position of a body from one point to another within a specific time or a well-specified time. Motion is the change in position of a body. A body here could be a human being, could be in an object that does not have life. So, but it's changing its position. Maybe from a point here, imagine we have a body here like this, moving from point A to point B to point B. So as long as it moves like this within a specified time, so it will still be within a time. Within a time, we refer to it as a motion. So that's how it is analyzed. So we have it like that. That's how motion is analyzed. So we'll be looking at a lot of things around that. That leads us to equations of motion. So we'll be discussing some things around equation of motion. So we'll start with first the first equation of motion. Looking at equation of motion, equation of motion, we have the first equation of motion. We have v is equal to u plus at. V is equal to u plus at. With this with linear motion. That's linear motion. Here, my v is final velocity. My u is initial velocity. Then my a is my acceleration. Then t is my time taken. The unit of this is in meter per seconds. This is also meter per seconds. This is meter per second square. While this is seconds. That is that. Seconds. So that's how the time taken is. So we have the final velocity, initial velocity, acceleration, then t time taken. For example, for the initial velocity, imagine that I'm starting here. So maybe I want to move from this point to the other point there. As I stand there, my initial velocity is 0. If I move like this to the other side, my velocity can be maybe 4 meters per second. And that will be my final velocity. Provided that's where I'm going to stop. So as I'm standing there then, my initial velocity is 0 and I move here, my final velocity maybe is 4 meter per second. Then the time taken, maybe the time I stood there for is at 0 seconds. When I got there, maybe I got there at 4 seconds, the final time will now be 4. Do you get such illustration? So that's the basic thing. Imagine your daddy's car at the front of your house is at that particular moment that it's at rest. Whereby I will say an object is at rest, that object is not in motion. It's just standing. There's no movement. The initial velocity is 0. That's referring to the u here. Then when it start moving, maybe you as a scientist, you are considering its movement from where your daddy is till the junction. The final velocity is now maybe at 5 meter per second. Then the time taken, the time it takes for it to move from where you are to the final destination. Maybe it took you 10 seconds. So that 0, when it has reached, the initial time is 0 seconds. When you get to that final destination, that time is at 10 seconds. So that's the kind of illustration for the first equation of motion. Then you have the second equation of motion where we talk about S is equal to ut plus half a t square. So if S is equal to ut, the only thing that is changed here is the distance. The other quantity we already understand it. So this is distance. So S is equal to ut plus half a t square. So we must be able to also identify that the unit of this is in meter. So we can talk about v square is equal to u square plus 2as. It's also another equation of motion. And how do you know which particular one to apply? The one you are going to apply will be the solution you are being told to solve as a student, then the quantity being given to you. Imagine you are given quantity that has to do with initial velocity, time, acceleration. So you are told to find the distance, you go for this. But imagine you are not given time. So you are given final velocity, you are given initial velocity, you are given acceleration. So you are told to find distance. So you are going to apply this and time is not involved. So those are just the way you'll be able to identify them. Yeah. But they are very simple and you need it to journey in physics. Then we have the fourth one. We have x is equal to v plus u over 2. Then t. So s is equal to v plus u over 2 times plus u, v plus u plus v, v plus u over 2 times t. Here now, you are given a particular distance, acceleration is not involved. You are told to find the distance. The quantity given to you are final velocity, initial velocity, and time. Then you make use of this. So those are the four major equation of motion. We'll be discussing this around that. So let's move into what we call average speed. Speed is defined as the rate of change of distance with time. So speed has to do with the rate of change of distance with time. It is a scalar quantity. What we mean by scalar quantity in physics is that it has magnitude. Magnitude means size or value, but it has no direction. So the average speed is total distance over time over total time. Here we place it as total time over total time. Total time over total time. That's right. You now see delta d over delta t. So here would have the final distance minus initial distance over final time minus initial time. So that is that for speed. So walk a distance of 3 kilometers in 20 minutes. We are told to calculate the average speed in distance in meter per second. So from here, I'll wait me to do like this. So my solution here, my average speed will be distance over time. So my distance there is in 3 kilometers, while my time here is 20 minutes. So what I need to do majorly is just for me to say My distance is 3 kilometer. I convert to meter. That will be 3 times 1000, which is 3000 meter. So my time, if 60 seconds is equal to 1 minute, so 1 minute, 20 minutes is x seconds. So x times 1 is equal to 20 times 60. That's 1200 seconds. So here will now be your average speed is d over t. So that will be 3000 over 1200. So our average speed will now be 0 here to 0. That will be 30 over 12. So here will now be 6 here, 2, 6 here, 5. So we now have 5 over 2. 2.5 meter per second. 2.5 meter per second. So from here, we converted our distance to 3 kilometer. From 3 kilometer, that's times 1000. That's where we have 3 times 1000 here, 3000 meter. In terms of the time, 20 minutes we multiply by 60. That was 1200 seconds, because 60 seconds is 1 minute. 20 minutes will be 20 times 60. So we just cross multiply. We place the one of the same quantity beside each other. 60 times 20, that's 1200 seconds. So x times 1, because we are made the quantities. The same quantity but they are at the right hand side, same quantity at the left hand side. Seconds here, minute there. That will be x times 1 is 20 times 60. That's 1200 seconds. So here we now say average speed is distance over time, which is equal to 3000 over 1200. So at the end, double double cancel double double, we have 30 over 12. 2 here to 2 6 here to 6 here 5. So average speed is 2.5 meter per second. For this question, a motorist traveling at 72 kilometer per hour had his eyes shut for 0.4 seconds. So we are told to find during a hard sneeze. Calculate the distance covered by him during this time interval. You know, when you want to sneeze, automatically you have to just in the reflex action. So it's just like when you are doing like this, ouch! Automatically, maybe automatically rather. What I mean is that definitely you shut your eyes, but the sneezing will take your attention. So that's what happened to the man. So we are told to find the distance covered by him during this time interval. So first thing is we must identify that in your solution you have your average speed identified as 72 kilometer per hour. That's for your average speed, 72 kilometer per hour. Your time is 0.4 seconds. So we want to convert this. So your average speed is 72 kilometer per hour. Here, we want to convert it to meter per second, since our time is given to us in seconds. So our average speed in meter per second will just be, because here means 72 kilometer over 1 hour. That's the meaning of this 72 kilometer per hour. That's 70 kilometer in 1 hour. So we are converting this to seconds, this to meter. In that manner. So here we now be multiply this by 1000, multiply this by 60, which is minute. We now multiply by 60 again, which is in seconds. That will be 72 times 1000. That's that. And here will now be 1 times 60 times 60. So from here we now say 72,000 over 60 times 60. That's 3,600. So this cancel this. So it now remains from here. It remains 720 over 36 there. So here 36 here 1, here is 2. That's 20 meter per second. So we have 20 meter per second here. So which so our average speed is 20 meter per second. So since our time is 0.4 seconds, so we can now say D, which is for average speed. Our average speed is distance over time. So here will now be average speed will be D is average speed times time. So D is now 20 times 0.4, which is B is 20 times, because in the real sense is 20 times a 4 will be 4 over 10. So 10 here 1, 10 here 2. So D is 2 times 4, which is equal to 8.0 meter. So 0.4 is 4 over 10. So I think we have D as 0 meter. So 8.0 meter. That's the illustration we have there. We have average speed at 72 kilometer per hour. We have t at 0.4 seconds. So our average speed would now be 72 kilometer per hour in meter per second. So here 72 kilometer over 1 hour. This will be 72 times 1000 over 1 times 60 times 60. So 72 times 1000, that's 72,000. Then here will now be 60 times 60, that's 3,600. Don't forget, I told you 70 kilometer per hour means 70 kilometer over 1 hour. We'll convert this to meter. We convert this to seconds. That's the illustration we did there. So 1 hour in second is 1 hour in minutes will be times 60. That 60 minutes to seconds will also be times 60. So that's 72,000 over 3,600. So the double zero here comes to double zero here. The remain 720 down 36. 36 here 1, 2. We have 20 meter per second here. So average speed is 20 meter per second. Time is 0.4 seconds. We can now say distance is average speed times time, in which our D is 20 times 0.4. So at the end we now have 10 here 1, 10 in 22, 2 times 4. That's 8.0 meter. So that's the illustration there. To look at a bird flies at 10 meter per second for 3 seconds. So if we have 50 meter per second for 3 seconds and 20 meter per second for 4 seconds, we are told to calculate the bird's average speed. So the best thing we'll do here, let's identify the parameter given to us first. So we have our solution here. We have our solution here. The first distance, let's look at the D1 is 10 meter per second. The T1 is 3 seconds. So our D2 is 15 meter per second. That's the second distance. The T2 is 3 seconds also. Then our D3 is 20 meter per second. Our T3 is 4 seconds. So looking at this now, the best thing we could do is, first of all, once we get the best average speed, let's get the average speed of the each time the bird flies. Because the bird flies in 3 consecutive times. So look at each time, the average speed of each of the times the bird flies. So before we'll be able to get the total average speed, the bird's average speed. So we'll look at here, we know that our A1, which is average speed, AS1, it will be D1 over T1. So we can now say D1 will now be average speed 1 times T1. So our T1 is equal to, what's average? No, sorry, this is the mistake. Please, this is AS1. The mistake. This is AS2, not distance. This is AS3. Please take note of that. That's AS3. So from here we can now get our D1. Please, those ones are average speed, not distance. Please take note. Those are average speed, average speed, average speed, not distance. So we can now say D1 will now be AS1 times t1. So d1 is equal to what my average speed 10 times 3. That will be 30 meter. So permit me to readjust. So we have our d1 is equal to we have as1 times t1. So my d1 will now be 10 times 3, which is 30.0 meter. So I have my d2 also be having speed 2 times t2, which my d2 will now be 15 times 3, which is 45.0 meter. Then I have my d3 is average is equal to average speed 3 times t3. So my d3 will now be average speed 20 times 4, which is 80.0 meter. So the total average speed now, the total average speed will now be will now be d1 plus d2 plus d3 over t1 plus t2 plus t3. So that's the best average speed now. It's like the best average speed is like total speed. Okay, it's like total speed, total average speed. So we've converted it to distance. So we now add everything. That will be 30 plus 45 plus 80. Those are the first distance, second distance, third distance over my time. We go back to the time where we have 3, 2, 1, 3 plus 4. So at the end, our average speed will now be 30 plus 45 plus 80. That will give us, doing our addition. So here is 75. That should be 155. Then, yes, the bed average speed should be 15.5 meter per second. Best average speed. So it's as simple as that. So permit me to explain again. We have the bed flight in three consecutive way. We have the first average speed as 10 meter per second. The time is 3 seconds. Here, the second average speed is 15 meter per second. The time is 3 seconds. The third average speed is 20 meter per second. The time is 4 seconds. So we want to find the distance at each consecutive time. So d1 will be average speed 1 times t1. That's 10 times 3. That's 30.0 meter. d2 will be average speed 2 times t2. That will be 15 times 3. That's 45.0 meter. d3 will be average speed 3 times t3. That will be 20 times 4. That's 80.0 meter. So average speed will now be d1 plus d2 plus d3 over t1 plus t2 plus t3. So the average will be 30 plus 45 plus 80 over 3 plus 3 plus 4. That will be 155 over 10. That's 15.5 meter per second. That's for the average speed there. So that's for the general average speed. That's all. Very simple. So please just reproduce it. It's a wide question. And the rate of change of distance move with time in a specified direction. You can also say, that's why you see me raising that. I did not see that in a specified direction there before at the initial. So, because we have to be conscious of that. If you are putting the rate of change of distance move with time, you must put in a specified direction. And if you do not put it there, you just put in the rate of change of displacement with time. Then there's no need of specified direction. Then the difference now comes in. What's the difference between distance and displacement? Distance is the space between 2 points. For example, here, this is a point here, this is another point here. The distance between them is what we refer to as distance. But the distance between these two in a specified direction, imagine I put it as, oh, I'm here, I'm moving towards due east, I'm moving due east. That's distance in a specified direction. That's displacement. So distance is just a space between 2 points. But displacement is the space between 2 points in a specified direction. I'm sure that illustration is clear. So anytime you are measuring velocity, it has to do with displacement with time. Rate of change is a velocity from defined as rate of change of displacement with time. That's correct. Or rate of change of distance with time in a specified direction. So displacement is just distance in a specified direction. That's the difference. While distance is just a space between two points with no specific direction. Direction can be due north, due south, northwest, northeast, southwest, southeast, due east, due west. In all those geographical points. But when it come now here, we now say velocity can also be defined as the rate of change of displacement with time. So it's well specified like that. So it is a vector quantity, that is, its unit is meter per second, just like average speed. You know, average speed is distance over time. That one is constant. That other one is a scalar quantity. But here is the vector quantity. As we said, it has magnitude and direction. For uniform velocity, when you hear the word uniform, just like people wearing the same clothes, we talk about equal, something equal. So that means the quantity that makes up that particular quantity will make sure that they are equal. So here now we talk about uniform velocity can be defined as when a body covers equal displacement in equal time interval, no matter how small the time interval is. So we talk about equal displacement in equal time interval, no matter how small the time interval is. So for the uniform or constant velocity, we have equal displacement over equal time. I want to give an example here. Maybe if you have something like this, e.g., you have something like this, a range of displacement. Maybe you have from 0 meter, you move to 4 meter, you move to 8 meter, you move to 12 meter, you move to, let's say, 16 meter. Then that's 16 meter. Then that's for displacement. Then your time from 0 seconds, you move. That's all as far as the topic is concerned. Do your best to do your best to follow up again. Watch the video as many times as possible. We are going to release the second part of this motion this week as well. So just follow up via the link. Help us share. Tell your friends if they are going to have a next time. Then don't worry, we are releasing videos that regards your chemistry soon as well, and your mathematics. We can assure you we are done with synthesis as far as mathematics is concerned, and my wife has handled the junior part too. So we'll be looking at some other topics too in the mathematics. So next class we'll be looking at acceleration. Then after acceleration we'll move to velocity time graph. Please, I just got to beg you. Do your best to follow this. Just do your best. Hmm? Do your best to follow this. Once again, we want to appreciate those who have been subscribing. Thank you very much. We still need more subscribers. We can assure you, you are going to have a nice time with us. You're going to have a nice time with us. So, we're doing a lot around search. So, please ensure you subscribe and see that an avenue to learn more. Thank you very much. We love you. Pray God's presence will be with all of us in Jesus' name. So, enjoy yourself. Read, study hard. You can get relevant textbook. You can get relevant textbook like Day Facts, Physics, All-Inclusive Calculation in Physics, New School Physics, Platinum, Series. That one to involve as many subjects as possible. Should be around 6,000. And get that. Then also have your targeting facts. Have it for maths, English, physics, chemistry, biology. They are very, very important. They are what I've been using for the past, let's say, since 2020. That will be almost 5 years now, and that had value to me. So thank you very much. Still your tutor, Engineer Noe Adebayo. So wish you the best. So we'll be starting motion 2. By God's grace, we'll release motion 2 on Wednesday. But this one will be released today. By God's grace. We release today. We'll release motion 2 on Wednesday. So thank you. God bless you. It's strictly calculation. Then later we'll move to the theoretical aspect fully. But strictly for now, it's still calculation. We'll do some things around relative motion and some other ones later. So thank you. God bless you. I love you. I wish you guys the best. You're right.